Okay, so let's look at questions 4, 5, and 6 from the homework for the dot and cross product example. So on this one right here, we want to find the angle between here. And so our formula for this is going to be the cosine of theta is equal to the dot product of u and v over the magnitude product of u and v. And so first we have to find the dot product of u and v. And so let's see, all we do is multiply the first components together, which would be 10, plus the product of the second components together, which would be negative 35, and then plus the last one's right here, 3 times negative 9, which would be negative 27. And we'll add that all together, and we should get, let's see what we get here. We're going to get negative um, 52, I believe. Let's see. Yeah, that looks good to me. Okay. And so that's uh, our dot product for u and v. And then to find the magnitude is equal to the square root of the dot product of the vector upon itself. And so what we're going to do here, so to figure out the magnitude of this is going to be equal to the square root of the dot product if I were to do just the dot product of u with itself. So I'd have 2 squared plus negative 5 squared plus 3 squared because I'm just multiplying 2 times 2, negative 5 times negative 5, and so on. And so let's clean this up. So let's see, we're going to get the square root of 4 plus 25 plus 9, which then will give us the square root of, let's see what we get here, 34 plus 4, so 38. Um, okay, and so I'm missing just one last piece, and that would be the magnitude of uh, v. And so we'll do the same thing here. So we're going to get the square root of, let's see, 5 squared plus 7 squared plus negative 9 squared. And so we're going to get the square root of 25 plus 47, I'm sorry, 49, and then plus 81. And let's see, that would add together to give us 130 and then 155, I believe, altogether. 155. Yeah, that looks um, that looks good. Okay, so then what we're gonna do now is plug it into this formula right here, and then just let the calculator kind of take over from here. So let's see, cosine of theta is equal to the dot product, which was negative 52, over the product of the magnitude. So it'd be the square root of 38 times the square root of 155. And when I put that in my calculator, I'm going to want to put parentheses around my denominator. You could multiply that together if you really wanted to have a single radical. But let me grab my calculator and let's see what we get here. So first I need to make sure I'm in um, uh, degrees. I want my answer to come back in degrees because yes, they said they want degrees. Okay, so I'm in degrees. So then I can go ahead and figure out what this is real quick and then plug it in. That's how it's done in the video. And so let's see, square root of 38 and then times the square root of 155. Close that. So we get this right here. And so if you kind of want to visualize this on the unit circle, it's somewhere about like right here, right? That angle right there. Um, so let's go ahead and plug that in. Oops, there we go. So let's see, second cosine. We're going to take the inverse and we'll just go ahead and pop that answer in there and then close it. And we get that answer right there, which is 132 degrees, and then rounded, it would be 133. So you can see that right there, 133. So in my picture, actually, I guess it's this other side of it right here. And so it's actually this angle right there. It's that angle right there, because that'd be the negative angle, and we want a positive angle. So that's why it rotates 180 all the way over to here. And so then that's the angle, about 133 degrees right there. All right, let's look at the next one. So here, this is kind of more just definitions. And so in order to be orthogonal, that's just a fancy way of saying a 90-degree angle or a right angle. And so the only one that falls into that category is going to be the 90 degrees. Parallel, if you go back and look at the definition, it's going to be either 0 or 180. So that's why these two right here are 0, 180. Um, and then, because what happens is the vector is like this, and if it's 0, then the vector is directly on top of it, like that. And if it's 180, the only difference is the vector is going in the other direction. So 180-degree turn, it flips around, and it's actually still parallel right there. It just is going in the other direction. Um, and then 45 degrees, that would be, you'd have a vector like this, and then a vector something like this or whatever. And so you'd have a 45-degree angle between them. And so that falls into the neither category. So it's neither parallel or orthogonal. Once again, that just means that they cross at 90 degrees right there. And that's why that first one falls into that one right there. All right, and then our last one, this is determine if the given vectors are orthogonal, parallel, or neither. And so it looks like you were able to get the second two, but the first one gave you a little trouble. So we're doing the same thing here that we did on the first problem. So we have that cosine of theta is equal to the dot product of u and v over the magnitude of u times the magnitude of v. And so once again, we just kind of have to find those pieces of information. So we'll start with the dot product of u and v. So 1 times 2 is 2, plus negative 3 times 5 is negative 15. And so then that's going to add together to give us negative 13. So that's going to be the numerator in a minute. And then to figure out the magnitude of u, we're going to take the square root of the dot product of u with itself. So that's going to be 2 squared plus 3 squared. And so that's going to give us the square root of 4 plus 9, which is the square root of 13. And then we'll do the dot product, or I'm sorry, the magnitude of v, which then, let's see, that's going to, oh yeah, that's a negative 3, but that won't make it. Oh, I'm sorry. That will make a difference. I started looking at a different u. So let's see, let's fix that real quick. So let's see. All right. Sorry about that. Let's see. So 1 squared, let's see, is 1. Negative 3 squared is 9. So that should be the square root of 10. So sorry about that. Then let's see. Then here we're going to have 2 squared plus 5 squared. So we're going to get the square root of 4 plus 25, which is the square root of 29. And then coming down here, now we're ready to fill in that information. So let's see the cosine of theta. Let's see the dot product of u and v is negative 13 over the square root of 10 times the square root of 29. And so we need to go ahead and put that in the calculator again. So let's see, we'll grab the calculator. So let's see, this time we're going to have negative 13 divided by the square root of 10 times the square root of 29. And let's see, what do we get? So we get this value right here. So I already know it's not going to be parallel or orthogonal. because that's not going to give me either 0, 180, or 90-degree angles. So this is going to fall into that neither category. And so I'll go ahead and find the cosine inverse of this real quick just so we can see it. And so it's about 139-degree angle between those two vectors. And so that's why that one's going to fall into the neither category. Um, so to get orthogonal, I'd have to get the 90 degrees. So, all right, I think that does it. If you have some others, just let me know.